Okay, for this last assignment for the unit, we're finishing this up. We're going to use the kruskal test. Now here we have a table. Notice on the top are my alpha. So I'm going to tell you guys an alpha. So I'm going to ask you guys to test according to an alpha. And then here on the left, we have our degrees of freedom as close as we can, okay? So our close to we can are to degrees of freedom. So let me take a look at our work here. I'm going to tell you guys the steps. First step, we're going to state the hypothesis and we're going to identify the claim. The second step, we're going to find a critical value using the table that I just showed you. We're going to use our critical value. Step 3, we're going to compute the test value. And in here, I gave you guys a formula. We're going to arrange our data from smallest to largest. We're going to rank it. And we're going to use this formula. Big N is how many numbers are there all together, and little n is how many numbers are there per list. So we're going to see that in a little. And then we're going to make a decision based on our formula or our value here, the test value. We're going to compare it to our critical value. Remember, the critical value, we get it from the list. The test value, we get it from this formula. So for number 4, we're going to make a decision based on our result. And the last step, we're going to make a decision. We're going to summarize the results. Okay, so the study for this example, you're doing a research for calories in cereals. We're going to test 4 different cereals. We're going to, here on the list, I see I have brand A, brand B, brand C, and brand D. There's 4 different samples. 4 different cereals. So here's a sample of 4 different cereals. Show the following numbers of calories for the suggested servings for each brand. At our alpha of 0.05, is there a difference in the number of calories for the different brands? Okay, so to begin with, we're going to state the hypothesis and identify the claim. I'm going to say the hypothesis. So my H, no. Pretty sure that they come and say there is no difference in the calories that each of this cereal has. So I'm going to say the no hypothesis. There is no difference in the number of calories. The number of calories. That's pretty much what I'm assuming the cereals are saying. There's not a difference. My claim, my alternate is there is a difference. I'm going to come and say there is a difference in the number of calories. So we stated the hypotheses with a no hypothesis, the alternate hypotheses. And then here it says we have to identify the claim. So I'm going to say this one right here, the alternate will be the claim. Every time we do a study, we go with the alternate, right? We have the null hypothesis, basically what cereals have been saying. There is no difference in the number of calories. So I'm going to say there is. That's why I'm going to do a study, right? I'm going to go for my alternate. Now we're going to find the critical value. Okay, let's see. We're going to find our critical value here. We're going to be looking at our alpha as 0.05. How many brands of cereals do we see? So we have that our alpha is 0.05. I need some degrees of freedom. Okay, so we have 4 cereals, right? We have 4 cereal brands. So my degrees of freedom is going to be 3. 1 less. We're going to go to our table. And let me find my alpha, 0.05. It's here. My degrees of freedom is 3. So my critical value, according to our table, is 7.815. Okay. So here, find the critical value. According to our table, is going to be 7.815. Now we're going to compute the test value. Okay. Let me get a calculator. I'm going to use Excel. I like Excel as a calculator. So let me open my Excel here. Okay, let me look at my data here. So, okay, coming from the table that we had, brand A, it had 112, 120, 135. I'm going to copy my list. 125, 108, and 121. Let me leave 2 spaces in between. My brand B, the numbers were 110, 118, 123, 128, 102, and 101. Let me leave 2 spaces in between. Brand C, the calories were 109, 116, 125, 130, 128, and 132. We put 2 spaces in between. Brand D, the calories were 106, 122, 130, 117, 116, and 114. Okay, so I have 24 data here. I have the data for 24 things. So I'm gonna rank them from smallest to largest. From these numbers, I'm gonna rank them from smallest to largest. And I'm gonna say 1 is the smallest number and 24 is the largest number. All right, so, okay, so this is what I'm gonna do. I'm gonna see, they're all in the hundreds, right? So looking at the first 2 digits, I'm gonna go for those that are 10. So 100, from 100 to 109. Let me identify them. I have this one, I'm gonna put a letter, I'm gonna put an A so I can identify them. Okay. So that way I'm gonna do my first 4. My first, right? So from 100 to 109. So my first digits were 10. Okay. Which one's the smallest? 101, right? So this is gonna be 1. This is gonna be 2. Oh, there's another one I'm missing here. This is gonna be my 3. This is gonna be my 4. And this is gonna be my 5. Okay, so cool. Now let's take a look from 110 to 119. So basically the first 2 digits are 1. I'm gonna put a letter here. So here's 1, I'm gonna put a letter. This one, this one. I'm marking those that have the first 2 digits to be 1. Okay, so we stop at 5, right? So 6 is gonna be, this is gonna be 6. This is gonna be 7. Remember, going from small to large. This is 7. This is gonna be 8. Now we have a tide. I see 116 here, then I see 116 here. So those will be 9 and 10. However, we've done this before. 9 and 10. We're gonna do an average of 9 and 10. So I can even click on here. I'm gonna say average of 9 comma 10. And it tells me 9.5. Okay. So 9.5 and 9.5. So that was, instead of calling 1.9 and 1.10, I call it 9.5 each. So this is going to be my 11th And this is going to be my 12. Good. Okay. Now my first two digits are 1 and 2. Okay. So I got this one, this one, this one, here, 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 and here. Okay, so that was 9 and 10. Oh, no, I did 12, right? The biggest number that I've done, 12. So then I go 13. Here, this is 13. This is 14. Here it is 15. This is going to be 16. Then I have a tide here and here. So instead of calling one of them 17 and the other one 18, I'm going to do an average. So the average between 17 and 18 is 17.5. So this is 17.5 and this is 17.5. So that's 17, 18. And then here, this last two, this is another tide. Instead of calling one of them 19 and the other one 20, I'm going to do an average. Average between 19 and 20 is 19.5. I think I can do it without putting the letters. Now my 21 and 22, there's an average right here. Instead of calling one of them 21, the other one 22, I'm going to call each of them 21.5. And then this would be 23. And this will be 24. Okay, so I ranked them all. Let me add my ranks. So I'm gonna go sum, open parentheses, and I'm gonna highlight all of these. I added all my sums, okay? For my second list, my rankings is there. For my third list, let me add my rankings. And then for my last list, let me add my rankings. Let me do squared each of them. Now, why do I have to square them? Let me show you why. Let me come back to our formula here. R1 is basically the sum of my rankings, but notice how this is squared. So I added my rankings, but I'm gonna square each of them because I'm gonna do this formula later. So I'm gonna square each of them. So I'm gonna go back to my calculator. And I'm gonna say this numbered times itself. This numbered times itself. This numbered times itself. And then lastly, 68 times 68. So I squared each of them. You might be wondering, why did you do that again? Because this is my rankings of my first list, my rankings of my second list, my rankings of my third list, my rankings of my fourth list. But I know in the formula, I have the ranking of my first list squared, the rankings of the second list squared, the rankings of the third list squared, and the rankings of the fourth list squared. Now, that's why I squared each of those. Okay, cool. Now that we understand. Now, let me come back to my formula. Let me work on my formula here. Okay. 12 is just a 12. N, this big N, is how many numbers are there in my data, combining all of my numbers. There's 24 of them. So that's a big N is 24, not a big deal. They have a square parentheses here, 24 plus 1, not a big deal. Now here, I already have the R1 squared or have the R2 squared, but it seems like I have to divide them by each of these n's. And this little n is how many are in each data. There were 6 zeros on each data. So let's come back to my formula here. My formula here. I know according to my formula, let me just, each of these numbers, I know this number here. It is my first list all squared, my second list squared, my third list squared. So I have that part of my numbered. And remember how there's 6 on each? So what I'm gonna do, let me leave a space here. I'm gonna go this number divided by 6. Okay. And then I'm gonna go this number divided by 6 because there's 6 on that list. And then this number divided by 6. And lastly, this number divided by 6. So you might be wondering, okay, Mr. Leonzo, I'm lost. Okay, this number represents this. So R2 squared divided by N2. My ranking of my third list squared divided by how many numbers I had on my third list. My rankings in the fourth list all squared divided by how many I had on my list. Okay, now if you look at the formula, we have a parenthesis and we're gonna be able to add these numbers, right? So that's where I'm headed. I know for my formula before I have right here at the very beginning, I have 12 divided by 24 over 20, times 25. My big N, I have N on my formula. So that's not that bad. And then at the very end of my formula, I know this is times because they're together according to my formula, minus 3 times 25. Remember, big N is 24 because there's 24 numbers on my data. Okay, so I can do this. I'm gonna do this one first. I'm gonna go equals 12 divided by, then I'm gonna put parentheses at the bottom. So I'm gonna have 24 times 25. I want my parentheses at the bottom, so I tell the calculator to just keep them at the bottom. So I do that. My second number, I have to do this plus this plus this plus this. Basically, that's what I have in parentheses. And then at the very end, I'm gonna do equals 3 times 25. Okay. Now I'm gonna be able to do my critical value. According to my formula, had to multiply these first two numbers. Remember, 0.02 is this. That's 0.02. My parentheses, when I added these, that's this number. And I know how to multiply those. But then I have to go minus this number. Okay, so I'm going to have the calculator figure that out. I'm going to go here. I'm going to say equals the first number times the second number minus the third number. And there's my critical value. I'm going to round it to 3 decimal places. I'm going to call it 2.842. Clear all this. So my test value is going to be 2.842. Now we're going to make a decision. I have a critical value and I have a test value. Which one is bigger? I have my test value is 2.842. My critical value is 7.815. Well, my critical value is bigger. Now, because my critical value is bigger, then I cannot reject the null hypothesis. Okay, so I'm going to make a decision. Do not reject the null hypothesis. Okay, so what does that mean? Remember how the null hypothesis was that there's no difference in the number of calories among the cereals? I cannot reject it. So I'm gonna say, yeah, there is no difference in the number of calories in the cereals. Now I'm gonna summarize my results. I didn't reject my null hypothesis. So I'm gonna say there is not enough, not enough evidence to support the claim that there is a difference in the number of calories. Remember my alternate hypotheses. I came in, I said earlier, there is a difference. There is a difference in the number of calories. I did my study. My test value happened to be less than the critical value. So then I'm gonna be saying, okay, I cannot say there is no difference. I mean, I cannot say there is a difference. So the claim cannot be accepted. So I'm not gonna be able to reject the null hypothesis. So that's why I'm saying there is not enough evidence to support my claim. My claim was that there is a difference in the number of calories. So I don't have enough evidence to support that claim. So I'm gonna have to say there is no difference in the number of calories.